Good morning, seventh graders. It's me, Mr. Stark. It is Friday, and I'm doing some recordings for Monday and Tuesday of next week. So, Monday and Tuesday of next week, you will be in my class doing the Diffusion Lab. And I want to set that up a little bit for you today. So, diffusion in the Latin sense or in the Latin meaning means to spread out. Okay. And diffusion means, in ways that you might be familiar with, is that molecules will be moving from a high concentration to a low concentration. So if I drop a bottle of perfume in the front of my room, it's not very long before the people in the back of the room say that they can smell that bottle of perfume because the molecules are spreading out. Moving from a high concentration towards a low concentration. You may have experienced this in the hallway if somebody was spraying Axe body spray on out in the hallway and you walk behind it. It's going to be really strong, and pretty soon, as people keep moving down the hallway, the Axe body spray can be smelled down the whole hallway. And that would be a good example of diffusion. So again, diffusion is the movement of molecules from a high concentration to a low concentration. Okay. What we looked at last week when we put the eggs in the vinegar and dissolved, we had a chemical reaction, dissolved the shells off the eggs, but then we put the eggs in water, left one in water, put one in vinegar, and the other one went in corn syrup. So we had things moving, molecules moving across a membrane. That was the cell membrane, and that is a little bit different than diffusion. It's exactly the same as diffusion, except for the molecules are moving across a membrane, and that's called osmosis. So diffusion is the molecules moving from high concentration to low concentration, and osmosis is the same as diffusion, but the molecules move across a membrane. Hey, last week we did an experiment in class. I did a demonstration where we took an egg and we put it into the vinegar, and the vinegar dissolved the shell off of the egg, and so basically what we were left with was a big, large cell that you could deal with, or you could see and visualize in front of you. Okay, so when we did that, we ended up dissolving 3 eggs. One of them we put in water. Okay, and the water started to, because of the high concentration of water around the egg, the water actually went into the egg and it got bigger. Similar results kind of with the vinegar. And then on the opposite end of the spectrum, when we put the egg in the corn syrup, the water concentration was greater inside of the egg itself, and so the water then went from the egg into the corn syrup, and it actually kind of shrunk. You can see how the egg is considerably smaller than it was before. And as I do this, you can kind of see that there is a nice layer of water on top of the corn syrup. Okay, the layer of water is from the inside of the egg. Okay, today we are going to do it's called the Diffusion Lab, but we should really call it the Osmosis Lab, because we're using a barrier. Okay, so first of all, what we're going to do is we're going to use a bag like this. This is going to represent our semi-permeable membrane. This is going to be our cell membrane. Okay, we are going to put a small amount of water, maybe a half a cup of water, in this bag. Okay, and then we're going to put in there some cornstarch. Okay, about a teaspoon of cornstarch, maybe a couple of them. Kind of the same stuff that you use for making oobleck. We are going to then squeeze out some of the air and try and get this all set up here. And then we're going to squish this stuff and try to mix it all up so that the cornstarch and the water are mixed up nice and even. And then we'll take this and we'll set this off to the side just for a minute, put it in another cup so that we can get the next step ready, okay? We're going to use, the next thing we're going to do is we're going to put some iodine in a beaker of water. I put a little bit in there. I think I need a little bit more. So I'm going to open that up. You can be careful with that. You see that iodine will stain your fingers. So you do not want to get this on your clothing at all. I'm going to try and put about 10 or 12 drops in this cup. Okay, and then we're going to see what happens there. Kind of mix that up. There, we got a nice little mixture of iodine in there. Got it all mixed up. And so what we've got here now is we've got iodine in a cup, and we've got a baggie that's got some starch in it. And one of the things that you need to know about starch is that if iodine and starch come together, there'll be a reaction that happens. And you know what? I'm going to go and get some starch water and show you exactly what happens. So I'll be right back. Okay, I'm back. I've got some plain water, and I'm going to just put some starch in there, and I'm going to mix that up and show you what's going to happen when you put some iodine in the starch. So we've got the starch water. We're mixing this up. Tip my screen down just a little bit. And so we've got a white substance here. And then if I take a little bit of iodine and put it into the starch mixture, and I mix it up a little bit, you can see that there is a change in color and that this actually turns purple. Okay, so iodine and starch react and create a purple solution. Okay, so here's what's going to happen here is we've got this baggie over here that's got starch water in it. Okay, and there's no water coming through here, but I'm going to take this and I'm going to set it in the iodine solution for a while, for about 15 minutes, and then we're going to come back and see what we will observe. Okay? So our cornstarch solution has been soaking in the iodine for roughly 15 minutes, and you're starting to see some action here. There's a little line that goes right there. That is turning purple. That is showing that the iodine is actually going through the baggie and into inside the baggie and reacting with the starch. So we're going to let this continue on, and well, we've let it go on about another 20 minutes or so, and you can see that inside the bag, the starch is settled down to the bottom of the bag, and there is some dark lines in here. That is, and it's purple, and that basically tells me that the iodine that was in the cup has now come into contact with the starch inside the bag. The bag was never open or exposed directly to the iodine. The only way that this could happen is that the iodine from the cup had to pass through the baggie. And the baggie is a semi-permeable membrane, just like the cell membrane. Okay, the starch is very large, and it will not. It's too big to pass through the openings in the plastic bag. But the iodine is very small, and it is able to maneuver its way through the little openings in the plastic bag, and therefore the iodine is moving into diffusing or moving with osmosis through the semi-permeable membrane of the sandwich bag. So I am going to reinstall this, and we're going to let it work overnight, and I will start up a new video with the with what happens to the iodine and starch solution overnight. So we're going to stop this one for now. We're running out of time, and I will start up a new one soon. Bye.